Hi, AP Calculus students. Welcome to your last section. 7.2C, finding volumes using cross sections. In this video, we have something special going on because I made more little volumes that are meant to represent what we're doing, and you will again see why I'm not allowed to teach geometry. I made these 4 volumes and then I realized they all look the same. Anyway, I did my very best. So what's happening in this section is not all solids, of course, are formed by discs or washers, right? They're actually formed by different areas of cross sections, usually across some axis, which in calculus, we will be finding these volumes either across the x-axis or across the y-axis. So I have a couple of those. And let's go ahead and take a look at how do we do this. So what we are doing is accumulating areas, right? That's an integration. And so we won't have pi r squared unless we have circles or semicircles, right? So what we're going to be doing is deciding if we are collecting our cross sections across the x-axis perpendicular to the x-axis. If that is true, we will have a dx. Perpendicular to the y-axis, we will have a dy, right? From a low y to a high y, right? We will be integrating the area based on formulas that we have, right? We know the area of a square, of a rectangle, a semicircle, and an isosceles right triangle. So we will be writing different areas here, and we will be integrating from a lower x to an upper x or a lower y to an upper y. Okay, so let's go ahead and do, we are going to find the volume if we have squares perpendicular to the x-axis, if this is our base. So what we have in each one of these pictures is I made a base that the cross sections will sit on. And one side of the base is the y equals 2x line, right? Or if we're working in terms of y, x equals y over 2, and y equals x squared. Or if we're working with y's, x equals the square root of y. So notice what I have here is the y equals 2x line and y equals x squared. And I will have in each of these. I didn't put it on the first one because I figured we should draw that together, right? So each one of our bases has one edge that is straight and another edge here that is curved like a parabola, right? So each one of these bases, right, straight edge and parabolic edge. So here's each one of our bases, right? Okay. Now, so let's go ahead. Let's draw the base. Y equals 2x, right? That would be 0, 0, 1, 2, 2, 4. And then, so here's our y equals a 2x line. And the square root of a y equals x squared, right? 0, 0, 1, 1, 2, 4. There we go. So there's our base. And it's almost like you are pushing the base down, and then we are going to put squares on top of that, which will form a solid that we need to find the volume of. Notice that at the front part of this solid, the squares will be very tiny because the base is very tiny. And at the end, the squares will be very tiny and the squares get bigger in the middle. So the next thing we do when we're doing cross sections, as you will see from your notes, right, here's your notes here. Right, here they are. You have your notes in your hand. We're going to draw the region and shade it just very, very lightly. There we go. We're going to determine the type of cross sections that we have. We already have done that. And if they're perpendicular to the x-axis or y-axis, we are going to draw a base, very heavy, very thick, perpendicular to the x-axis or the y-axis for each of our areas, right? I'm going to draw a base of a square. I'm going to draw the base of a rectangle, the base, which would be the diameter of a semicircle, the base of an isosceles right triangle, which would be one leg, really nice and dark, because we're going to need that to write our area, and we want to be able to find it easily, right? And then, and we just draw our cross sections kind of up and down, you know, just to kind of get a depth of it. I'm not very good at it, right? It's hard for me to really do a good drawing. And so that's why I used Play-Doh. Your book will often turn the X and Y axis so you can see the solid more clearly. They don't do that on the AP exam, so I don't do that either. So here's the 4 examples at the bottom. Let's go ahead and do that. So we drew our base. Here we go. And we're pushing that base down, and we're going to put squares on top of it. So I'm going to make one edge of my square perpendicular to the X axis. So I make that really, really big, like I show those points clear, right? If I made another base of a square up here, down here, right, they would be much smaller. And then we make squares. It's hard to do that with depth though. I'm really not good at it. And these taps would connect here. Okay, but where I'm really looking is right here, is at the base of this square. So again, because my drawing isn't that good, I made one, right? So here's the base with the y equals 2x line and y equals x squared. And what's happening is the height of this volume is smaller at each point and bigger in the middle. And if I cut cross sections, right, across here, I would have little squares, bigger, bigger, bigger squares, little squares. So I'm trying to find the volume of this solid, right? Notice that it might be a part that we would need to produce that we don't have a geometric formula for. So notice that because we are perpendicular to the X axis, I am collecting my squares from a low X to a high X, right? My lower X is 0, my higher X is 2. I first write the area of a square, which is a side squared. And I have already recognized, because I'm perpendicular to the X axis and I can see how I'm collecting my squares, that I have a dx. The next thing I do is fill in my side squared, right? So let's fill in a side. It has to be in terms of X. So I have this lower upper function minus lower function. The length of this side of this square that I did not draw well, right, is 2x minus x squared. So this is a side, here's its length, and it's being squared. So the next thing I have to do is actually square this expression. So let's see, that would be 4x squared minus 4x cubed plus x to the 4th dx. Now, if it's okay with you, I do have my paper here because of course I practice these ahead of time, right? It's like an actress with your lines. And I just like to make sure, you know, it's so easy to make mistakes. Like I did on the 7.1c video, a little mistake. So I like to check to make sure my little details, just like we do in class. Okay, please remember I haven't actually integrated yet, right? All I did was square. So now I'm going to integrate. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent and divide by the new exponent. Here we go. I'm going to evaluate that from 0 to 2. Let's take a look. My f of b, when I put a 2 in, this is going to be 8 times 4, 32 thirds minus 16 plus 32 fifths. Now, minus, I would normally do my f of a, but it is a 0, and so I will have a 0. Okay, so let me go ahead and got a little bit of math to do here. 32 thirds. Now, they would do this to you on the AP exam where you have to do this math yourself. So I will right now. How about if I will first do, this is 32 thirds minus 48 thirds. And I'm going to just keep my 32/5 for a moment. So that would be negative 16/3, right? And plus 32/5. I'm going to get a common denominator of 15. So that would be multiplied by 5. So that would be negative 80 multiplied by 3, 96, and not so bad, I get 16/5. Is the volume. All right, let's go to the next problem. This time, our base is the same, the y equals 2x line and y equals x squared. And they want rectangles on this base perpendicular to the x-axis with a height of 2. So what I did is same base, right? And what I did is I tried to make the top the same height, a height of 2 all the way across. And it would have these edges on it, right? So it would be flat on top, right? Because it's the top of a rectangle, right? Notice though that the rectangle base would be very thin at the top and bottom, and in the middle, the base of the rectangle would be bigger, but the height would always remain 2. Let's find this volume. Okay, so y equals 2x line, y equals x squared, and I made a base of the rectangle right here perpendicular to the y-axis. So I can draw other bases perpendicular to the y-axis, but I would always have to make sure that they have the same height, a height of 2. They always have a height of 2, right? And then it would connect across the top, okay? But let's look at this base right here. So let's integrate. We are perpendicular to the y-axis plus I can see. I'm collecting rectangles across the y-axis. That is from 0 to 4. My rectangle is base times height, and I see that this is in terms of y. Okay, my base for my rectangle is going to be right minus left, and it has to be in terms of y, and my height is going to be 2 all the time. So I'm just going to bring this 2 to the outside, right? And my base then, right here, is the square root of y minus y over 2. That's how big my base is. If it's okay with you, since we're about to integrate, I'm going to go ahead and write that as the square root. All right, let's go ahead and integrate. We have 2. Not going to forget my 2. I'm going to add 1 to the exponent and divide by the new exponent. Right, so that's 2/3 y to the 3/2 minus, going to add 1 to the exponent and divide by the new exponent, y to the 4th over, y squared, right, y squared over 4, right, not a 4 in both places. There we go. And we're going to evaluate that from 0 to 4. If you don't mind, I'm just going to check my paper again, right? Since I did the work before, I think we are definitely on the right track. Okay, f of b. Notice I won't have to do my f of a again because it's 0. So here's my 2, right? When I put a 4 in, the square root of 4 is 2, cubed is 8, times 2 is 16/3, minus, this is going to be 16 divided by 4. Which is 4. So in the interest of saving room, I'm going to write my 4 as 12/3. So I have 4/3 times 2 is 8/3. Is this volume? Okay, let's try semicircles to the x-axis. This is going to take a little bit more But they'll often have semicircles on the AP exam. So y equals 2x line, right? Y equals x squared. I made a base right here of my semicircle. So I have a half circle. Let's go ahead and write our integration. Okay. So I am going to be integrating a semicircle, right? That would be pi over 2, right? So one circle, the area is pi r squared, obviously. So I have a half of that. Pi over 2, I'm going to need the r squared here, right? And this is perpendicular to the x-axis, so I will have a dx. Now, let's be careful with the radius here. Okay, this is, got to be a little careful with this. Oh, let's take a break for a moment before we do the radius squared, and let's look at what it looks like. It's kind of an egg shape, right? So notice the base, right? Y equals 2x line, y equals x squared. Notice that with semicircles, then it has a rounded top. And as you get to the points on each end, right, it's a very small semicircle, and the height gets bigger in the middle. Okay, and we are going to find this volume almost like an egg shape, except chopped off on one side for the y equals 2x line. Okay, now let's handle the radius this way. I see what I have marked here is a diameter. So I'm going to write this diameter and then divide it by 2. And that will be the radius. And I won't forget to square because it's 1/2 pi r squared, right? So let's see, that would be upper minus lower, right? So we have, this is 2x minus x squared, right? Okay, there's the diameter. We're going to divide that by 2. So the radius is here, right? And it's being squared. Okay, now stick with me here for a minute. Okay, in the denominator, this is 2 squared, that's a 4. Okay, so I am going to write, here's my pi over 2 on the outside, and I'm going to call this 1/4 in the denominator. So I have pi over 8. So if you notice then, isn't it always true if you have cross sections that are half circles, right? That you always have 1/2 pi r squared. And then if you have the diameter and you're dividing by 2 to have the radius, then you always have a 4 in the denominator. So won't you really always have pi over 8 when you are collecting semicircles, is my idea. Okay. Now, I want to show you here is take a look here. You're like, oh my Lord, I have to square this and then go ahead and integrate that again. And that's the key word, is again. Take a look over here. Didn't we already square this? Right? Didn't we already square that? Didn't we already integrate this expression? And we evaluated it from 0 to 2, right? And that's what we're doing, from 0 to 2, right? Forgot to write that in for the upper and lower x's, right? So take a look right here. Didn't we already do that? Is the idea. Didn't we integrate over here and we found it was 16/5? So what you thought was really going to be difficult again is really easy. I have my pi over 8. I already did this integration. That was 16/5. There we go. The 8 cancels and leaves a 2. And we have 2 pi over 5. All right. All right. I felt like I made a little mistake somewhere, and I did. That's why I paused. Take a look here. Negative 80/15 plus 96/15 was 16/15. So, right. Isn't it amazing how we can do all this and then these silly little things? So in case you're like, uh-oh, that was 16/15ths, not 16/5. Not, we're back and we fixed it. Okay, so over here then, there we go. Right, I had the same integration. The 8 and the 16 left the 2, and I have 2 pi over 15. So sorry about that. Hope I didn't throw you off. We went back and fixed it. If you're like, oh, poor Miss Culver. Let's go on. Last one. Number 4. Let's say you have the same base and you are collecting isosceles right triangles on it. So I tried to do that. Here's my base line parabola. And on the top, I tried to make, so notice that there is now this flat edge, right? So where the straight edge is, right, there's a height, right, for the leg of the isosceles triangle. And then on the right towards the parabola, it slopes down in a straight line and hits it. So I tried to do that. So if you notice, right, here's the y equals 2x, right, and it has this height. And then on the parabola here, y equals x squared, I tried to make a straight edge down to it. So we are trying to find this volume. All right, so let's go ahead. Our bases are perpendicular to the y-axis in this case. So we are again going to be going from 0 to 4 on the y-axis, right? And triangles are 1/2 a base times a height. And we are in terms of y because we collected up the y-axis perpendicular to it. So what I did is here, right, I drew our usual base and I made a base of the isosceles right triangle. It is a leg. And I drew a couple more right up the y-axis, but I showed this one really clearly. So notice that the base of this triangle then is right minus left, and this is the square root of y here. So we're going to do base times height. So the square root of y, right, minus y over 2, right? And the height is the same because the legs are the same on isosceles right triangle. So we are going to be squaring that. Okay, now this is going to take a little bit of work. I'm going to show this as the square root of y. I'm first going to square and then integrate. So what this means is I'm going to need some room, so I will be erasing over here. But let's go ahead and do this first. So we have 1/2, 0 to 4. When I multiply y to the 1/2 times itself, I will add the exponents and get a y. When I multiply on the outside, this is a y times a y to the 1/2. So I'll show the two pieces. So that would be minus y to the 3/2 over 2. So this is just when I multiply the outside, right? Just checking my work. And when I multiply the inside, I get the same thing. So I have 2 of those and the 2's cancel. And then when I multiply the last term, it's positive, a 4 in the denominator, and y squared in the numerator. Okay, I'm going to clean this up. Not going to do any integrating, just going to clean it up on over here. And then go ahead and integrate. 1/2, 0 to 4 of y minus y to the 3/2 plus y squared over 4 dy. Again, because the details, there's so many details, if you don't mind, I'm just going to check, make sure that I'm doing okay so far. So I have y minus y to the 3/2 was doing well. Okay, let's go ahead and integrate and I'll check it again. 1/2 y squared over 2 minus, I'm going to add 1 to the exponent and divide by the new exponent. That's going to be 2/5 y to the 5/2. There we go. And then plus, add 1 to the exponent, divide by the new exponent. This is going to be y cubed over 12. And I'm going to evaluate that from 0 to 4. Luckily, I only have to do the 4. Quick check again, making sure I did okay. Right, not like my 16/15 over here. Good, doing okay so far. All right, I'm gonna come on up over here, so. And do my F and B. Luckily, I don't have to do my F of A because it's 0. So 1/2, when I put a 4 in, that is 8 minus, when I put in an 8 here, sorry, a 4 here, the square root of 4 is 2. 2 to the 5th is 32, times 2 is 64/5, plus 4 cubed is 64/12. There we go. I think I can reduce 64/12. So I have 1/2, 8 minus 64/5. And then let's see, I can take a 4 out of each, so that'll be 16/3. Okay, let's see how well I can do this. Let's see. So this is 40/5 minus 64/5 is negative 24/5 plus 16/3. All right, running out of room again. I'll go above. That is 1/2. I'm going to get a common denominator of 15. So I'll multiply by 3 here. So that's 12, carry the 1, 72 plus, right, 80/15. There we go. And that would be 1/2 times 8/15, which the 2 and the 8 cancel and leave us a 4/15. A 4/15. Did you see I did that again? Like I missed the 15 and put a 5. And there's our final answer. Sorry that was so long, but that was a lot. And it's your last section and it can be difficult. So we'll have plenty of time to finish up before spring break. Thanks for hanging out with me on this.